What's going on, guys? This is Luke. I'm going to be doing a very quick, very basic introduction to digital forensics. So yeah, this is for people who are thinking about a career in digital forensics, but they don't really know what it is. It's also for people that are just interested in it, and it's also for people that have just started studying it. So this presentation is not for people who already have the basics, and it's not for people that want to try and cover the tracks. So what is digital forensics? Digital forensics consists of four main parts. You've got to collect the evidence, you've got to examine the evidence, you've got to analyse it, and finally you've got to report what you found. Digital forensics is used in any sort of larger crime that sort of could benefit from having a digital forensic, someone studying that to have a look at the evidence. So yeah, any big crime will always have digital forensics, because there's always going to be a computer involved in a crime nowadays. So yeah, first thing that we're going to need to know about is types of data. There's a lot more than this, but yeah, the two that we're concerned about today is volatile and non-volatile data. So volatile data is like RAM. If you know what RAM is, it's random access memory, and non-volatile is like a hard drive. So the main difference is that RAM requires power to keep its information stored, and hard drives don't. So, for example, if you turn off your computer now and you turn it back on, you don't want the operating system to be deleted from your hard drive. That's not very good. Or if you're copying something over from a USB flash drive to another computer, when you unplug it, you don't want the data to be gone. So yeah, we've got a couple examples of volatile sort of media. That would be RAM, dynamic RAM, and static RAM. Don't worry if you don't know what they are, it's just examples. You should know the non-volatile ones like hard drive, read-only memory, USB flash drives, and CDs and DVDs. So yeah, just make sure you know what they are. Why we care? Well, if we've got evidence, we want to make sure that if we turn off the computer, we don't lose evidence. We want to keep as much evidence as possible, because turning the power off could lose that crucial data. So the first main stage is called acquisition, and acquisition basically involves grabbing the data. That's one of the main points of acquisition. You've got to do a few other steps, but acquisition, grabbing data, just remember that. I'll talk about the other steps, which is duplicating the data, hashing the data. So yeah, so data acquisition. Data acquisition sort of appears when you come into a computer that is turned off. When it's turned off, you're not going to have that volatile data like RAM. It's going to be gone. There's sort of less risk to it, but one of the disadvantages is you don't get that volatile data. So yeah, the computer's turned off. First thing that you're going to do is you're going to grab the hard drive, and you are going to have a forensically clean hard drive on you. So this is hard drive number 2. So this is the original, we'll call it number 1, and you're going to have your sort of forensically clean hard drive called number 2. Now what I mean by forensically clean is there's going to be no data on that hard drive. No previous data. I think in digital forensics they call it residue data. So, for example, you can't just unplug your hard drive that you're using right now to watch this video and take that to a crime scene. You've got to make sure that the hard drive is being rewritten over with either ones or zeros multiple times. That means that there's no residue data left on that hard drive. So we've got this hard drive, and we're going to copy over hard drive 1 to it, and this has got to be a bit-to-bit copy. What I mean by bit-to-bit is there can't be a single bit out of those gigabytes or terabytes of data that is different. It's got to be an exact match, and the way we find out whether it's an exact match is we are going to hash hard drive number 1, and this will, if you know what hash is, you know it sort of uniquely identifies a piece of data. So if I hash hard drive number 1 and it comes up with 2AB46DC, I don't know, something like that, and I hash hard drive number 2, we have to make sure that they match exactly. If they do, then we've got an exact bit-to-bit copy, and that's great. If we don't, then we're going to have to clean this hard drive again and copy it over again, and then hash it again. So, thing is with data acquisition, if you cock up, then the original evidence could be tampered with, and you could lose it, and it's not going to be justifiable in court, which this crucial evidence could just be dismissed in court due to negligence, yeah. So there's also live acquisition. Live acquisition is just the opposite of dead acquisition. So the computer is turned on this time. So what that means is we get the volatile data, like RAM, which is awesome, because RAM, if you know what RAM is, it stores temporary data. So say if you're making a Word document, your coursework, your tax info, I don't know, whatever's in that Word document, and you don't hit save, and you turn off your computer, that's when you lose that file. So when you hit save, you're saving it to the hard drive, but currently it's in RAM. So in live acquisition, you get to deal with volatile data, which can also be very crucial data. So it's the exact same steps. We get the hard drive, the RAM, the whatever, we're going to clone it to hard drive number 2 and hash it and make sure that the hashes match. So yeah, same again, if you cock up, you could lose data that could be very crucial to convicting someone. So when we do live acquisition, we've got to do something, and dead acquisition, we've got to have something called a write blocker. So this is a hardware write blocker, and this is a software write blocker. And what it does is it just disallows any write commands. So you got read commands and write commands. So if you've got a book, you don't want people writing in the book. We want to keep it like the original book. You don't want someone's notes when you buy a book. Well, you might do, but yeah. So you want to make sure the media is read-only. That way, because if you tamper with the data, then same again, it might not be able to be used in court, and that is not good. So what is hashing? Like I described before, hash basically uniquely identifies something. So in this picture, we've got the eagle flies at midnight, and if I send that to a hash function, which in this case is MD5, it will churn out this. So this is a hash. Now if I put in the eagle flies at noon, the hash is going to be completely different. It's called the avalanche effect. If something's different in the input, the output is completely different. So yeah, we can put in the data from the hard drive, and it's going to put it into the MD5, and it's going to make a hash. Now, hashing is not compression, so you can't decompress this and get the eagle flies at midnight. It doesn't work like that. So it's a one-way function. So you can go this way, but you can't go this way. That's a no-no. So it's just going to uniquely identify something. That's basically the main point you need to get out of this. So hashing is used in passwords, storing passwords in databases. So say if my password is pass123 and I hash it, and I get something like 2BCD348, I can't put it back into the hash function and get this out. So that's why you have to sort of crack passwords when you get the hashes of them. You've got to try hashing a load of different things until you hash it and it equals the same to the outcome of the hash. So yeah, when we hash the evidence, we're going to hash the original copy of the evidence. So same again, here's the original evidence. Here's our forensically clean hard drive with the evidence on. So we're going to copy the evidence and make a copy of it onto our clean hard drive. Then we're going to copy, we're going to hash the original evidence, hash the clone of the evidence, and make sure that both hashes are equal. If that's done, then that means we've got an exact bit-to-bit copy of the evidence, which is awesome. That's what we need. So artifacts. Here's more of a fun part of digital forensics. So an artifact is basically something that intrigues the investigator. So, for example, if you're looking at a fraud case and someone's got a file called creditcardnumbers.txt, that is an artifact. That is something you are going to be interested in. So here's an example artifact, hiberfile.sys. So when you, on a Windows machine, if you've got the option to hibernate, turn off and restart, and there's also sleep, I think. So when you hibernate, in fact no, when you sleep, it's more of a power, it saves power. And what it does is it will sort of just put your computer in a state, and yeah. But when you hibernate, what it's going to do is the RAM, the contents of the RAM, is going to be saved to a hard drive, in the hard drive under the file of hiberfile.sys. So then the computer's using less power because the RAM is turned off, so it's just, you know, more efficient in the power sense. But what we can do is we can look at this hiberfile.sys and see what was previously in the RAM. So we can see any previous Word documents that they were editing, any programs that they were running, that sort of stuff. And that can contain artifacts in there, which are very important. Spooling. Spooling is basically, it's not just used in printing, but printing's quite an easy example to sort of talk about. So say if this is my computer, and we've got a printer, okay, but say there is also computer 2, computer 3, you're in an office, there's loads of people, there's loads of computers, and they're all sending print jobs to this printer. Well, say if computer 2 sent the first print job, computer 3 sent the second, and we are the 5th in line. What a print server would do is you send it to, it said this is the print, this isn't the printer anymore, this is the print server. So you send it to the print server, and then the print server will send it to the printer. So this is going to be spooling. It's going to be creating spool files of your sort of document. That way you don't have to wait until the printer's ready. It'll just do it when it's ready. So basically this spool file will contain the document that you have printed, and if that spool file isn't deleted, then you're going to be able to see what was previously printed, and that could be very relevant to the case. So if someone was printing out invoices of stolen equipment, or printing out credit card numbers or whatever, in that spool server, you can use that as evidence against them. So one thing to note is deleted data is not deleted. If you go right click and empty recycling bin, it's not deleting the data. The way operating systems work is you'll have, say this is some memory, you got a load of chunks of memory. So say file 1 is covered here, so this is one file. When you click delete, all that's happening is the operating system is saying, alright, this piece of memory is unallocated now, so we can use it. It's not deleting it. So, for example, later on, say if your hard drive's getting quite full and you're making a new file, it'll see that this space is unallocated, and it'll probably write over it. It'll rewrite over it and de-unallocate it, and then it'll be deleted. So it's kind of a weird concept, but yeah, the only way to delete something is to nuke it or shred it. They're just two terms, but they're both the same thing. So we would rewrite over everything. Like when you create a forensically clean hard drive, you're rewriting over everything with ones or zeros multiple times. That way there is no previous residue data. So the same thing's happening here. So when you delete a file and you clone the hard drive and you use some digital forensics tool like FTK to look at the hard drive, you can see the unallocated data, which is data that the Windows operating system has deleted. It's not deleted it, it's just unallocated it. So yeah, sorry if that's a bit confusing. So thumbnail cache, this is another cool little one. So say if we've got this awkward image here, and we right click and save it, and it'll be saved here in a file, well, pictures or whatever. But in here, documents, encase, cases, Mac export, thumbnail cache. Here is an example sort of file with they call it thumbnail cache, and basically when you are in the the Windows File Explorer, whatever it's called, you don't want the images to be this large one. So Windows will make a cache of that image, like a copy of it, that's going to be, instead of 810 by 580, it might be 110 by 40. That way it's using less processing power and memory to display this smaller image. So say if you delete this or unallocate it, whatever, it's gone. They've actually encrypted it, they've deleted it, they've done whatever, and they haven't done this, then you will still have a copy, or a smaller copy of that image on their hard drive. So yeah, again, that could be an image of, I don't know, child porn or whatever. They could just be used as evidence against them. Windows registry, this is a big topic. There's all sorts of stuff that can be found in here. But this Windows registry is basically a database of Windows configuration files. You can't just type in Windows registry in the, when you press the Windows button. When you press that button next to the Alt key and type in Windows registry, it doesn't come up. You've got to run a command to get the Windows registry editor open. And that is because you shouldn't really touch it unless you know what you're doing. This contains all sorts of very vital files, like System32. You don't want to be messing around in System32 unless you know what you're doing. And this is a treasure trove of information for digital forensics investigators. There is all sorts of stuff in there. You can see whether someone's clicked a link or they've actually searched it, if that makes sense. Like if someone's been accused of child porn again, and they type in child porn, in the Windows registry you can sort of tell whether they've typed in child porn or they've just clicked a dodgy link or a virus has downloaded it. All sorts of stuff like that. Metadata. Metadata is data about data, and that sounds very confusing, but a very sort of easy example that will sort of clear that up for you is when you right click and go in properties on a song, then it will tell you song name, the album from the song, the track number, the year, the genre. That is data that's related to the song, but it's not sort of the song's data. It's data about data. Well, this metadata can give lots and lots of clues. So an example would be the person who took this picture, or so if it's child porn again and there's a photo and you look at the metadata, that metadata might say what camera it was taken from, and you find that the exact same camera on the crime scene. Then you can put two and together and say you've taken that photo, you were there at this time. It could say the metadata could be the time taken. That way this person was there with that camera at that time and took that picture. So yeah, another one would be link files. Say if you have a file called Project 2013 and you right click and create shortcut, and you made the shortcut and you have later down the line you've completely deleted it, encrypted it, shredded it, nuked it, whatever. There's no chance of a digital forensics investigator getting to that file. Well, they have found a file called Shortcut Project 2013. Or it might not be Project 2013, it might be child porn folder, I don't know, whatever. Stuff like this can contain very vital information. So yeah, there's no more slides. This was just a quick demo of digital forensics, and I hope you enjoyed it. Don't forget to like, subscribe, and adios amigo.